Hey Valley Metal, welcome back to another math lesson. Tonight we're going to talk about the inverse property of multiplication. We have a double target for this one. But first let's start off with a trivia question. What crazy type of 8-foot wave flooded the streets of Boston in 1919? Let's get to the targets officially tonight. We have a double target. 5.6a, I can write the multiplicative inverse of a number, and 5.6b, I can use the inverse property of multiplication to solve equations. I'm going to put these two together even though we might be separating them in terms of how we look at them in class. Let's get to it. Our problem du jour. Let's do it. Daniela spends a half an hour dancing each night after school and a half an hour reading. Write a multiplication problem to solve this situation and then solve it. All right, so what we want to do is find out how much time she spends. So we have the 1/2 times 2 equals t. So 1/2 times 2 over 1, because that's what 2 is 2 over 1. I can multiply straight across like I did right down here, and I'm going to get 2 over 2, which equals 1. Daniela spends 1 hour dancing and reading all together. But what I want you to notice that these are reciprocals or multiplicative inverses. Anytime the denominator of one fraction is the numerator of another, and the numerator is flipped to the denominator, you're going to get 1. So 1 becomes the denominator, 2 becomes the numerator. They're flipped. It can be 1. I could change this to 11. I could change this to 12 or to 22. And I could change this to 22. I could change this to 11. See how I flipped them? Whenever you have that, these are called reciprocals, so the multiplicative inverses. You're going to get 1 when you multiply these together. Always. All right, that's what we're going to be talking about tonight. Here we go. Here's the term I use, multiplicative inverses. Two numbers with the product of 1. Take a look at 1/3 and 3 over 1. Those are opposites or reciprocals. They're going to multiply out to be 1. Same thing with 1/4 and 4 over 1. Again, reciprocals or the multiplicative inverse. Take a look at this example. 3/4 times 4/3. Those are reciprocals or the multiplicative inverse, correct? So take a look. 4 times 3 is 12. 3 times 4 is 12. You're still going to get 1. They just cross each other out. So we can use this property to solve equations. And I know it's a little fuzzy yet, but let's just try some examples. Here, find the multiplicative inverse of 2/5. Well, if you flip the number, flip the fraction, it's 5 seconds. That's the multiplicative inverse. If I multiply those together, 2 times 5, it's 10. 5 times 2 is 10. By flipping them and multiplying, you always have the same two problems on the top and the bottom, so of course you're always going to get 1. Let's just have you try these three right here. Go ahead and find the multiplicative inverse of 3/5 and so on. All right, let's see how you did. Did you flip them? 5/3, good. This one, flip it. 17/15, it's good. And 8/6, flip it. 6/8. So these are a little more complicated, following the multiplicative inverse of 2 and 1/3. You just take and make it into an improper fraction. So 2 times 3 is 6 plus 1 is 7/3, and then flip it. 7/3, flip it to 3/7, and you'll get a product of 1. Try this, 1/2. Go ahead and do that. Okay. It becomes 3/2. That's the improper fraction. Did you remember to flip it, though? Remember to flip. Okay, same thing here. Try that one. All right, let's see. 4 times 5 is 20, plus 1 is 21/5. But did you flip it to get the multiplicative inverse? Okay. Let's see if we can use this property to solve some problems. All right, so we've got this problem. We'll look at the example over here. 2/3 n equals 6. This is right from the book if you want to take a look. So we've got the equation written. Now we want to get n by itself, so we're going to multiply it by the opposite, which is 3 over 2. We have to multiply the other side by 3 over 2 as well. But look at 3 times 2 is 6. 2 times 3 is 6. 6 over 6 is just plain old 1n or n. But I have to do the other side by 3 over 6 too, or 3 over 2 as well. So I'll multiply across. 3 times 6 is 18. And I got that 2 in the bottom. 2 times 1, because it's 6 over 1. It's going to give me 18 over 2, or 18 divided by 2, which is 9. I'll show you in more detail the steps right here. So here I wrote a problem. 3/4 n is 3. So multiply by the inverse, just like they did. Multiply each side by 4/3. So I did that. Here's 4/3 and 4/3. Well, 4 times 3 is 12. 3 times 4 is 12. Show that here. Now I have to multiply the other side by 4/3. 3 times 4 is 12. 1 times 3 is 3. So I've got 12 over 12, which is 1, or just plain n. And I have to solve this. 12 divided by 3, which is 4. If I substitute in my answer, 3 times 4, it's 12 divided by 4 is 3. See how that worked out? Okay, let's try another example. Sorry, just making sure I got my problems the same here. All right. N divided by 4 equals 3. I've put this one up here so that you can take a look at as I go through. It's just another example. Why don't you try this one? All right, let's see how you did. Well, I multiplied the opposite of n over 4, which is really 1n over 4, is 4, or 4 over 1. So I changed it to 4 over 1 down here for you. But I have to multiply this side by 4 over 1, or just 4 too. So here, my 4's cross off, where I get 4n times over 4. So I can cross the 4's out. Either way, I'm going to get n. And over here, I have 3 times 4, which is 12. Substitute that back in. 12 divided by 4 does equal 3. Okay. I think it's time for you to try one. See if you can solve this. And again, I put this problem back up there to help. Why don't you go ahead and give it a shot. Are you stuck? Did you multiply both sides by the opposite of 2/5, which is 5 over 2? Let's take a look. Here's 5 over 2. Multiply this side by 5 over 2. So these guys here, I have these little things here to show you that you could just cross this one out and this one out, because 5 and 5 cross off, and 2 and 2 cross off too, because we can do that like we've been doing in multiplication. Or you can multiply 5 times 2 is 10, 2 times 5 is 10, and they cross out there. But take a look at this side. We've got 10 times 5 over 2, so I put 10 over 1. 10 times 5 is 50. 1 times 2 is 2, so the next step is n equals 50 seconds. Of course, 50 divided by 2 is 25. If I throw that back in, I've got 2 times 25, which is 50, divided by 5 does equal 10. That was my quick check at the bottom. Have you try one more. Sorry, this one here. Go ahead and give that a shot. All right, let's see how you did. Well, multiply both sides by 6, or 6 over 1, if that makes it. You want to do that, you can do that. So the 6's will cross off, leaving us n. But I have to multiply this side by 6 too, so 5 times 6 then will give me 30 on this side. So then I just get n equals 30. Substitute that back in to my original equation. 30 divided by 6 does equal 5. All right, same problem, here we go. Let's recap. All right, write the reciprocals of these numbers here. Go ahead. See how you did. Did you flip it to 4/5? Good. Here's an improper fraction. Well, the improper fraction for this mixed number is 17/3, but did you remember to flip it to 3/17? That's what most kids do. They forget to flip once they make the mixed number into an improper fraction. All right, why don't you try solving these two problems? Go ahead. All right, let's take a look. Clear the way. Well, multiply both sides by the opposite of 1/4, which is 4 over 1. That crosses off, and you just get plain old n. But you have to multiply this side by 4 over 1 too. 8 times 4 is 32. 32 over 1 is still 32, so we have 32 there. You can substitute that in. 32 divided by 4 does equal 8. All right, go ahead here. This one, we had n over 7, so we really have to multiply it by 7 over 1, because this is like 1/7. So 7's cross off, leaving us just plain old n on this side. 2 times 7 is 14 over 1. It's 14. Substitute that back in. 14 over 7 does equal 2. You can see the answers. All right, here's your ticket to the show. Go ahead and try solving these two for tomorrow. And the trivia question. What crazy type of 8-foot wave flooded the streets of Boston in 1919? Believe it or not, it was a molasses wave. Yeah, weird. I'm sure that wasn't very fast moving. But a molasses tank burst, causing this giant wave to flood it, and this is what the aftermath looked like. Crazy, huh? It was a sticky situation. But ching. All right, thanks so much for listening.